Hello everyone. In this video we'll learn how a 7 segments display is being controlled by an Arduino controller via a 8-bit shift register. The 7 segment display can be seen here. The 8-bit shift register, the 74HC595 can be seen here. It has an interface of 8-bit parallel 8-bit versus the 7-segment display. We have coded the Arduino to reflect coding from digit 0 to digit F in hexadecimal base, and each time by a for loop, by defining a for type loop, we get to define the exact coding to the shift register. It's being latched inside the shift register, and then it's being displayed. It's being driven into the 7-segment display. We have here the parallel interface, which include each resistor in series to the relevant LED pin inside the 7 segments. It's called 7 segments because there are 7 segments here in this display. Each segment is being controlled with a different pin, with a different terminal. And actually, when LED is lit up, the exact pin and the shift register enforce 0, low voltage, with this versus this pin, and then current flow into this pin via the specific resistor into the shift register's exact pin, and then this lights up the exact segment in the 7-segment display. So let's look at the code. Here we see we define the pins number 11, 12, and 13 from the Arduino as latch, clock, and data pins versus the shift register. They are all defined as an output pins. And here we define the coding to allow display of each of the 0 until F displays. 0 is represented with this representation, and 1 is with this representation, and so on. And in continue, next we have the loops. There's a loop that defines the going up order from 0 to F. Here we get to count. We have a I as a counter from 0 to F. In each action we define the latch pin as low, so we can write into the shift register. Then we write the content, the relevant content in the array, and then exact array index from 0 to F. And then we raise the latch pin to high, so there cannot be any writing into the latch, into the shift register. And then we wait half a second, 500 milliseconds between each code writing, between each digital representation writing. So this goes from 0 to F, and another loop which goes from F to 0, because we get to subtract. We get first F index inside the array, inside the coding array, and then we go to the E, and then the D, and then so on until 0. Here we also get a 500 milliseconds delay between each writing. So let's see the simulation and get to see how the digits are changing. So here we see 0 to F, then it's waiting another, and it goes back from F to 0. We can control the delays to represent a faster or slower display rate. Thank you everyone, and see you in the next video.